Hi everyone, this is the last section from Module 3, 3.5, and it's on shapes of graphs. We're going to learn a few new vocabulary terms today and how to describe the shapes of different graphs. So we'll start with symmetry. There are a few different types of symmetry, but today we're going to focus on what's called line symmetry. And line symmetry says if you have a graph that you can draw a line down the middle of somewhere, and it can be any kind of line, but if you can draw this vertical, horizontal, any kind of line where you cut the graph exactly in half and make it so it folds over on top of itself, or like it's a mirror image, then we say that that graph has line symmetry. So here's an example. If you look at the graph here, the name of that is called a parabola. But that dotted red line where it says x equals 3, if you notice, as you draw that dotted red line in, if you imagine taking the blue graph and folding it over on the red line, it's exactly the same on both sides. It's a mirror image, or it folds over on top of itself. Here's another example of line symmetry. This is more of kind of like a W-shaped graph, but the same thing. If I take that dotted red line, which this time is actually the y-axis, it's right down the middle, but if I were to take this paper and fold it over on that dotted red line, it's the same on both sides. It folds right over on top of itself, or you could think of it as one side is a mirror image of the other. That's what we call line symmetry. So let's talk about our football question from before. A couple sections ago, we did a question about throwing a football, and I asked you about the intercepts of that graph. Well, today, let's talk about line symmetry, because this graph does have line symmetry. In fact, I'll draw it in there. If I draw this vertical line right here at x equals 20, I can tell it's 20 because it's marked on the x-axis. What I get is a shape that's a mirror image. Or if this were on paper and you folded that paper over, the graph folds right onto itself. So we definitely have line symmetry, but what we want to do is interpret it, tell what it means in terms of the problem. Well, remember what we have here is you're throwing a football, and the football is going up and then coming back down and hitting the ground. So this point up top, that's basically the highest point that the football reaches. But the fact that it's symmetric means this part right here, where the football is going up to that point, is exactly the same as this part right here, where it comes back down. And that's what it means to be symmetric. So you throw this football, it starts going up, 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 and then as soon as it hits that highest point, it comes back down in the exact same way that it went up. So up and down are basically the same arc, and that's what it means to interpret in terms of a problem. Okay, our second topic for this section, our second two vocabulary words that go together are increasing and decreasing. So whenever you're talking about a graph, when you're getting information from a graph, always imagine a point moving along it from left to right, like I just did with that football question. The football started going up, 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 and then down, 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 down. So I imagine it was actually the football moving across the graph. Well, that's what you do when you're getting information from a graph, is imagine a point going, whatever it's direct, I mean, it can go up and down, it can go straight, it can be a line, whatever it does, always imagine a point moving from left to right. Now, whenever that point is moving upwards, we say the function is increasing or getting bigger. That makes sense. If the point is moving up, it's getting bigger and bigger and bigger. Whenever the point is moving downwards, we say it's decreasing or getting smaller. So what we're doing is we're imagining a point moving from left to right. It's always left to right. And as that point moves along the graph, anytime it's moving upwards, we say the function is increasing. And anytime it's moving downwards, we say it's decreasing. Now, a whole graph can be completely one thing or the other, but a lot of times it's a little of both. So let me give you an example of all three of those things. Let's start here with a graph that is just increasing only. So basically what I want to do is draw a graph that's just going up, 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 up forever and never turns, never starts going back down. Now the easiest way to do that is with a straight line. If I just draw a graph like a line like this, that's an example of a graph that's increasing always. If I start at that bottom left corner and I start, imagine I'm starting with a point right here. As the point moves from left to right, it's going up, 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 up forever, increasing. Now, you can also have a function that's decreasing only. Now, the easiest way for me to do that would be to show a graph, a line, but doing the opposite, down instead of up. But just to show you that it doesn't have to be a line, I'll show you kind of a different one here. Let's say we have a graph that does something like this. Oops, had a little jump there. Let's say a graph, so it's not a straight line. It does curve a little, but it never curves back up. It's still, and imagine, I'll do it in a different color so it stands out. Imagine if I start with a point right here, and I'm tracing the graph, it's moving down, 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 down the whole way. Never turns back up. But like I said, a lot of graphs do turn. So here's an example of a graph that has some increasing and some decreasing in it. So let's say I start at the very end over here, as far left as you can go. And if I start tracing the graph, it's increasing, 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 up, 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 until you hit that point right there. And then it turns, and it starts decreasing. So from this point, it's down, 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 decreasing. And then it turns again, and this point is up, 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 increasing forever. So the two parts that I highlighted in red are increasing, but that point here, or that part here in the middle that I highlighted in light blue, that's decreasing. So what you have right here, 3 examples. You can have a graph that's increasing only, just up forever. You can also have a graph that's decreasing forever, just down forever. But very likely, a lot of these graphs are going to have parts of each, where it goes up and then down and then up and maybe down again and up again, and it keeps twisting and turning forever. So we want to have a way to describe, to talk about a graph and tell when it's increasing and when it's decreasing. Now to do that, we're going to use what are called intervals. Intervals are a way to talk about parts of a graph. Now when you use an interval, we're going to be talking about values of x. And we're going to be using terms like greater than and less than. So you might say it's increasing when x is greater than 10. Or it's decreasing when x is less than 5. Or maybe it's increasing between two numbers. It's increasing when x is greater than 2 but less than 7. So you're going to have these intervals. You're going to say when x is between these two numbers, it's doing this. When x is bigger than a number, when x is less than a number. But we're going to use values of x, and we're going to use less than and greater than. So let's wrap it up with an example of that. So here's a function that looks a little bit like the one I just showed you. And I ask you, where is this function increasing and where is it decreasing? So what I'm going to do for the notes, I'm going to highlight it in color like we did before. And I notice the first part of it, like if I start up at that top left corner, the first part is decreasing. So I'll use blue again for that. So if I start with this point right here and I start drawing the graph, as I'm moving from left to right and I'm tracing the graph, it's down, 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 down until you get to right here. So that part right there that I just highlighted, that's decreasing. But then once you hit that point right there, it turns and all of a sudden it's increasing, up, 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 up until you get to that point right there. So that red part is increasing, and then it turns one more time, and for the rest of the graph it's down, 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 down forever. So what you want to do is you want to give intervals of x. Remember, we said it's all about x values. So what you want to do is figure out the x values where it's changing. So like right here and right here, what are those x values? And we're going to approximate it. I'm going to say that one right there looks to me like it's about -3 on the x-axis. And this one right here looks like it's about 1 on the x-axis. We're going to approximate. It's close enough. So let's say that that's where those x values are. When x is -3, that's where my graph changed from the blue one to the red one. And when x is +1, it changed from red back to blue. So this is how we're going to say this. Let's do increasing first. Increasing when, now the increasing was the red part, and the red part happens when x is between -3 and +1. Now the way we can say that using greater than and less than, you use that double inequality where you write -3 is less than x and x is less than 1. That's our way of saying x is between -3 and 1. And if you don't want to use the inequality, you can actually say it in words. You can write in words, x is between -3 and 1. Or you can say in words, when x is greater than -3, but less than 1. So if you'd rather write it out in words, you can, but this is the shorthand, this is the quickest way to write that. Okay, now let's say when it's decreasing. Decreasing when, now you should have two answers here. There's two blue parts to my graph, two places where it's decreasing, so you have to say both of them. Now the first one is everything less than -3. Remember, when you're doing values of x, less than is to the left and greater than is to the right. Less than is smaller or to the left, greater than to the right or bigger. So it's decreasing when x is less than -3. That would be this blue part over here. And when x is greater than 1, that would be this part over here. So you're saying you basically covered all the x values. You say if x is some number less than -3, some number to the left of -3, then the function is decreasing there. If your x value is between -3 and 1, it's increasing. And if x is greater than -1, it's decreasing again. So this is how you describe where a function is increasing and decreasing using intervals. It's always about the x values, like on the x-axis, and you're always talking about either like between two numbers or less than some number or greater than some number or something like that.